Welcome viewers. In this we'll see the parallel AC circuit. This parallel AC circuit means the impedances are connected in parallel. The combination is excited by the AC source, then it is called a parallel AC circuit. The series circuits are available in separate video. The link is available in the description box. You can see that. So in this parallel circuit, we have two branches available. In branch 1, resistance and capacitor are connected in series. In branch 2, resistor and inductor is connected in series. These two branches are connected in parallel. It is excited by the voltage V equal to Vm sin omega t. This is the current I, total current. That is due to parallel, it is split into I1 and I2. So we have two branches available. These two branches are connected in parallel. Now we'll see what is the reactance, what is the impedance of these branches. So the branch 1 having resistor and capacitor, branch 2 having resistor and inductor. So the resistance of the branch 1, XC1 equal to reactance of the branch 1 XC equal to 1 divided by 2 pi FC1. Because of capacitor, this is the reactance. This 2 pi can be written as omega, so that 1 divided by omega C1. The reactance of the second branch is XL2. Second branch containing the inductor. So 2 pi f L2, that is omega into L2, right? The branch 1 capacitor termed as C1, in branch 2 inductor termed as L2 for the simplification purpose. So based on the reactance, we can able to calculate the impedance. The impedance Z1 is nothing but R1 square plus XC1 square. Resistance and capacitance. In branch 1 we have resistance and capacitance. Then what is the phase angle pi 1? Tan inverse XC1 by R1. Similarly, the impedance of the second branch Z2 equal to square root of R square plus XL2 square. Second branch containing resistance and inductance. Similarly, what is pi 2? Tan inverse XL2 divided by R2. Now we will go to another three terms: conductance, susceptance and admittance. What is conductance? It is reciprocal of resistance. Resistance means opposing the flow of current. Conductance means it will allow the flow of current. What is susceptance? Susceptance is nothing but the reactance. The reciprocal of reactance. Reactance means it will that also oppose the flow of current. Susceptance means it will allow. What is admittance? That is reciprocal of impedance. Reciprocal of impedance is nothing but a admittance. Now we'll see these three terms for this branch 1 as well as branch 2. For branch 1, conductance G1 is written as R1 divided by Z1 the square. Susceptance B1 is written as XC1 divided by Z1 square. It is positive because in the inductive circuit, capacitive circuit, it is positive. Then admittance is nothing but Y1 equal to square root of G1 square plus B1 square. So it is nothing but this is the resistance, reactance, impedance. It is a reciprocal. It is a reciprocal of the resistance, reciprocal of the reactance and reciprocal of the impedance. So that similarly we are writing this formula. Similarly for branch 2, the conductance G2 equal to R2 divided by Z2 square. Then susceptance B2 equal to XC2 divided by Z2 square is negative because of inductance. Then admittance Y2 is square root of G2 square plus B2 square. Now we will find the total conductance. Total conductance is G equal to G1 plus G2. Total susceptance is B1 minus B2. Total admittance is G square minus B square. This is G square minus B square for the entire circuit. Similarly, the branch current I1 equal to V into Y1. I2 is V into Y2. Total current is V into Y. The phase angle can be calculated tan inverse B by G. If it is lagging, if B is negative, it will lagging. Similarly, cos pi is nothing but G by Y. So in this video, we analyze the parallel RLC circuit. Two branches available. We calculated impedance and reactance for branch 1 and branch 2. Then We also calculated inductance, susceptance, admittance of branch 1 as well as branch 2 as well as the total for the total circuit. Thank you. Welcome viewers. In this video, we will see the solved problem based on the parallel AC circuit. The resistor, inductor, capacitors are connected in parallel. For that, we can see the solved problem. First, we will see the problem 1. The two impedance of parallel circuit can be represented by 20 plus J15 and 10 minus J16. So, this is nothing but a complex form, rectangular form. 20 plus J15, 10 minus J16. If the supply frequency is 50 Hz, find the resistance, inductance and capacitance of each circuit. So, the given data will take this is a Z1 first impedance 20 plus J15. So, this plus J represent that is the inductance. If it is minus J, that will be the capacitance. Because of current leading and lagging, we can easily identify plus J is the inductive circuit, minus J means capacitive circuit. So, by comparing these two, Z1 equal to R1 plus JXL, so that R1 equal to 20 ohm. The XL will be 15 ohm. Similarly, Z2 equal to 10 minus J16, that in the standard form we can write Z2 equal to R2 minus JXE. So, by comparing these two equation, R2 equal to 10 ohm, XE equal to 60 ohm, right. So, the plus J represent inductance circuit, the minus J represent the capacitive circuit. Now, we got the values R1, XL, R2 and XE. By using this, we can able to find the value of resistor, capacitor and inductor. First, consider the circuit 1. R1 equal to 20 ohm, XL equal to 15 ohm. So, this XL is nothing but 2 pi F into L, that is equal to 15. So, that L equal to 15 divided by 2 pi F. So, substitute the value 15 divided by 2 into pi into 50, that is equal to 48 millihenry. By solving this, we will able to find this is 48 millihenry. Then we will go to the second circuit. R2 equal to 10 ohm, XC equal to 60 ohm. XC means 1 divided by 2 pi FC, that is equal to 60. So, what we need is C. So, bring the C here and 60 in the denominator. So, C equal to 1 divided by 2 pi F into 60. So, C equal to 1 divided by 2 pi FC into 60, that is 2 into pi into 50 into 60, that is 53 microfarad. Micro means 10 to the power minus 6. So, we calculated capacitance, inductance, the resistance we already identify from the equation R1 and R2. Now, we will go to the second problem. The two circuit, the impedances of which are Z1 equal to 10 plus J15 and Z2 equal to 6 minus J8 are connected in parallel. If the load current supplied is 15 ampere, what is the power taken by each branch? The two impedances are given and current value also given. We need to find what is the power taken by each branch. So, from the given data, we can able to analyze Z1 equal to 10 plus J15. So, this plus J refers it is a inductor. So, Z1 equal to R1 plus JXL1. So, by comparing these two, R1 equal to 10 ohm, XL1 equal to 15 ohm. Similarly, the second network Z2 equal to 6 minus J8. This minus J refers is a capacitive circuit. So, R2 minus JX2, XC2. So, by comparing these two equation, R2 equal to 6 ohm. Similarly, XC2 equal to 8 ohm. So, now we are able to identify R1 value, XL1 value, R2 value and XC2 value. Now, we will go to the impedance. So, Z1 is given 10 plus J15. Now, we will convert this rectangular form into polar form. In order to go for a addition, subtraction, multiplication, division, we need a polar form. How will you find the polar form? Polar form means we have magnitude and angle. Rectangular form means real term plus imaginary term. Polar form means magnitude and angle. How will you find the magnitude? That is nothing but square root of 10 square plus 15 square. That is square root of square of real term plus square of imaginary term. We need to take the square of these two and we need to add. Then how will you find the tan theta angle? Tan theta imaginary term divided by real term. Tan inverse 15 by 10. So by simplifying we got 18.03 magnitude, angle is 53.6 degree. So this one directly we can calculate using the calculator. This is a manual method to find the formula. This is a formula to find the polar form, magnitude and angle. So you can directly, you are able to find this value by using the calculator also. Rectangular to polar, polar to rectangular conversion available in the calculator. Similarly, Z2 equal to 6 minus J8. So the magnitude is nothing but square root of 6 square plus minus 8 square. This real term and imaginary term. Then tan inverse minus 8 by 6. So by simplifying we got 10, magnitude is 10. The angle is minus 55.113 degree. Now Z1 and Z2 is converted into polar form also. So based on that we can able to find the current. In order to calculate the power in each branch, we need a current in each branch. Because in parallel circuit, the current is divided. It will divide into I1 and I2. So we need to find the I1, current flowing through the first branch. Similarly I2, current flowing through the second branch. So by using current divider rule, the I1 equal to total current multiplied by impedance of the other branch. This is, we consider the first branch I1. Impedance of other branch is Z2 divided by total impedance Z1 plus Z2. So the current divider rule is current in the first branch equal to total current multiplied by current impedance of the second branch divided by total impedance. Right. Now the Z1 and Z2 values are available. We will substitute this. So I is nothing but 15 ampere, angle is 0. Z2 is 10 to the angle of minus 53.13. Just now we calculated Z2. Similarly Z1 plus Z2. So while adding we can use this rectangular form. While multiplying we can use polar form. So 10 plus J15 plus 6 minus J8. So the 15 plus 10 is 150. Then angle is minus 53.13. So we can add here 10 plus 6 is 16, 15 minus 8 is minus 7J, is plus 7J. Now in order to go for this division, this rectangular form should be converted into polar form. How will you find the magnitude? Square root of 16 square plus 7 square. Then tan inverse 7 by 16. Right. So after that, after simplification we got this value is 17.46. The angle is 23.63. Now we can divide. How will you divide? We have to divide this magnitude 150 divided by 17.46. What about the angle? For the division, the angle is the angle should be subtracted. While this angle is going to numerator, it will become negative. Or in general, for the division the angle is subtracted. For multiplication the angle should be added. Right. So 53.13 in this angle will subtracted, this also negative. 53.13 minus 23.63, both are minus, so it is minus 76.76 amperes. So now we calculated the I1 value in a polar form. 8.6 is the magnitude, minus 76.76 is the angle. Now we will find the I2 value. By using the Kirchhoff's current law, I2 equal to I minus I1. Actually, I equal to I1 plus I2. From that, I2 equal to I minus I1. So the I is the total current, 15 angle of 0. The I1 just now we calculated 8.6 with an angle of 76.76. Now in order to go for a subtraction, this Polar form is again converted into rectangular form. 1.97 minus J 8.37. So this is simplified. Again it is converted into polar form, that is 15.5 with an angle of minus 32.7 degree. Now we got the value of I2 also. The magnitude is 50.5, angle is minus 32.7 degree. So from the current value we can easily identify the power taken by the branch 1 and branch 2. So power taken by branch 1 is power dissipated in resistance of branch 1. So the power taken by branch 1 is nothing but power available dissipated in the resistance. So I1 square into R1. So the I1 square is 8.6. The magnitude we calculated 8.6 square into R1 value is 10. So by simplifying we got 739.6 watts. The power dissipated in the first branch, that is power dissipated in the resistance, is 739.6 watts. Now we will go to the power dissipated in second branch, that is nothing but power dissipated in resistance of branch 2. I2 square into R2. The I2 we calculated 15.5 magnitude, 15.5 square into 6. So by simplifying we got 1442 watts. The power dissipated in the second branch is 1442 watts. So we calculated I1 and I2. By using that we calculated power dissipated in branch 1 and branch 2. So in this video we discussed the solved problem based on the parallel AC circuit. Thank you.